All right. Today's lesson is about something that we call significant figures and math of significant figures in chemistry. So one of the things that is important to understand about significant figures and what they mean is it's more of an issue about what we do with numbers we collect in lab. So the problem with significant figures and the way that we teach significant figures is the problem is that in order to understand, we have to learn some rules first. And so that always makes it a little bit like dry and boring, but I just think it's super fascinating. Significant figures are that I get really excited about it. So what ends up happening then is that we need to understand what significant figures actually are. Now, significant figures are the number of digits that the measuring device can allow you to record. So what I mean by that is if I measure something with a ruler, okay, the ruler has, most rulers, at least the ones that we would use in our class, allow you to go to 2 places past the decimal point. So for example, if I measure something that's like, say, this long, it might be like, I don't know, 7.85 centimeters. The 7.85, all of those numbers are important, right? But because of the ruler, I can't say it's 7.8597632 because I don't have enough information. Okay. If I use a balance and I put an object on the balance will only go to 2 decimal places. So if I put a mass with, or if I put an object on that ends up with a mass with like 325.26 grams, all of those numbers are important. And if I'm using a graduated cylinder, the graduated cylinders in this class tend to go to 1 decimal place. So when I record my value, I can say that it's like 9.8 milliliters, but I could probably never say 9.9983 because it's just not set up to do that. Now, when I learned these, how to do significant figures, there was like 7 or 8 rules that I had to memorize and incorporate and become part of my soul. But you don't have to memorize those rules because we developed a cheat code. And by we, I think it was Miss E who came up with this cheat code. So here we go. Write dot. What that means is that if you're looking at a number and you're asked to identify the number of significant figures that value has inside of it, you start by looking and identifying if that value has a decimal. So if the value has a decimal point in that number, you draw an arrow coming from the right toward the right until you hit the first non-zero digit. Once you've hit the first non-zero digit, what ends up happening is then you are able to start counting everything that's left over and identify the number of significant figures. So here are 3 examples that we're going to go through. And if you haven't opened up your note packet yet, you might want to. At least pretend. So at this point, 0.00292, I'm going to take my arrow and come in from the right because there's a decimal, and I'm going to stop at that 2. Everything, including that 2 to the right, 1, 2, 3, is considered significant. So the 292 has 3 significant figures. Sig figs is what we call them. All right, so next, with 123.90, same rule, I'm going to come in from the right with my arrow, draw a line, and I get to that 1. And so now everything, including the 1 after that, is significant. So 1, 2, 3, 4, 5. So in this case, this number has 5 significant figures. Lastly, the 0.0292092, same thing. There's a decimal. So I'm coming in and I'm drawing an arrow, and I get to that 2. So I start counting 1, 2, 3, 4. So that gives me 4 significant figures. So again, gentle reminder, you should have your note packet out and taking notes. And probably not on your Chromebook. Should have our note packet out. Probably not on our Chromebook. But it is you not. So here we go. The other rule that has made significant figures very simple for many is the fact that if the number does not have a decimal, then you come in with an arrow from the left until you hit a non-zero digit. And when you get to that non-zero digit, you then go ahead and it's best I got. And then you start counting from there. So in the case of 6,390, there's no decimal, so I'm going to come in with an arrow from the left. I know. So, all right. So I came in from the left, and now I start counting that non-zero digit until I get the rest of them. So, So the 9, the 3, and the 6 are significant. So I would say that this is 3 significant figures. Now I kind of would like to make the point that we don't drop the zeros. So you wouldn't say, oh, this has 3 significant figures, so I'm just going to write 639, because that would be the equivalent of me saying to Jaden, hey, you owe me $6,390, and he says, hey, here's 639, and I'm like, where's the rest of it? And he's like, sig figs. And then I pull open my drawer and I get my baseball bat and I cap him in the knee. Because, well, this is not real. So you see what I'm saying there? Okay, now, next, 120,000, no decimal point. I'm going to do the same thing. I'm going to draw an arrow, coming in hard like that. And I see the 1 and the 2. So I'm going to count 1, or the 2, 1. So this is 2 significant figures. And then lastly, the 693, I'm going to draw that arrow coming in. I get to the 3, and I count 1, 2, 3, and it's 3 significant figures. All right, so now that we've gotten those rules down, okay, we're going to give you an opportunity to try these. So go ahead, give this the old college try. Nope, I lied. The old Greendale try. All right, so going through these answers here. 250, no decimal. So I'm going to come in from the left with my arrow, like that, and I count the 5 and the 2. So this tells me it's 2 sig figs. Okay? 250 with a decimal means I'm going to come in from the right. So now I'm going to count 1, 2, 3, 4, 5. 5 sig figs. Okay. The 0.00320, there's a decimal, so I'm coming in from the right. Stop at that 3. So 1, 2, 3, 3 sig figs. 4.0020, there's a decimal, so I'm coming in from the right. And then I count 1, 2, 3, 4, 5. 5 sig figs. 5,000 with no decimal point. Coming in from the left. Get to that 5. Count. 1. 1 sig fig. 0.086. There's a decimal point, so I'm going to come in from the right. Draw count the 8 and the 6. 1, 2. So it's 2 sig figs. And then lastly, 6,250 with a decimal point. Coming in from the right-hand side. 1, 2, 3, 4. 4 sig figs. Questions? All right, then. Now we're going to talk about what to do with it. When you are asked to multiply or divide with significant figures, the answer that you report is based on the fewest number of significant figures in the problem. So if the problem has, well, there's rounding, fewest number of sig figs. I think the easiest way to like, this is wordy. I'm just going to show you. So here we go. Looking at the first problem, 1.20 times 20.42 times 10.1. So I'm going to put that in my handy dandy calculator. So 1.20 times 20.42, not 2, 20.42 times 10.1. My calculator gives me an answer of 247.4904. Now, most of you get all up in arms and you're like, well, what do I have to write all that? And the answer to that question is absolutely not. But there are some rules that you have to follow. So here's the rule. Because we're multiplying and dividing, our answer is reported with the fewest number of sig figs in the problem. So what does that mean? It means I go back and I assess the numbers in my problem. 1.20. If there's a decimal point, I'm going to come in from the right and I count 1, 2, 3, 3 sig figs. 20.42. There's a decimal point coming in from the right. 1, 2, 3, 4, 4 sig figs. 10.1. There's a decimal point coming in from the right. 1, 2, 3, 3 sig figs. So if my answer has to have the fewest number of or the same number of significant figures as the fewest number in the problem, I'm going to count. Draw an arrow because there's a decimal. 1, 2, 3. So then I draw a line and I see that 4 cannot round up to 7. So my final answer becomes 247. And what would my unit be? Centimeters cubed, right? Because centimeter times centimeter times centimeter is cubed. Just like 6x times x times x is x cubed, right? Yep. Okay. So what this tells you is that I had, in my math problem, I had 3 sig figs, I had 4 sig figs, and I had 3 sig figs. So my answer also has to have 3 sig figs. It cannot have 4. Going to do the next one. 123.97 divided by 316.1. Calculator gives me an answer. My calculator answer is 0.3921860171. How do we determine the number of significant figures that we report? Well, we have to look at the numbers in the problem and determine the number of significant figures given. So 123.97, there's a decimal. I draw an arrow and I count 1, 2, 3, 4, 5. There are 5 sig figs. 316.1, draw an arrow. I count 1, 2, 3, 4. 4 sig figs. So my answer has to have 4 sig figs. So I'm going to draw an arrow and start counting. I got to my first non-zero digit. 1, 2, 3, 4. I draw a line to help me remember what to round, and I see that 8 will round that 1 up. So my final answer is going to be 0.3922. Now my unit this time is going to be grams per milliliter, because nothing happened. I divided them, so they didn't really change. So far, so good? All right. So if that's multiplying and dividing, we clearly need to know what we are doing when we add or subtract. And adding and subtracting is a little bit different. Adding and subtracting has nothing to do with significant figures and has everything to do with decimal points. So what we do is this. We do the math, we add or subtract, we get our answer. We then look at the number in the problem, at the numbers in the problem, and count the number of decimal points present. And the fewest number of decimal points present are the ones that we report our answer to. So that looks something like this. 126.9 plus 5.12. So handy dandy calculator, 126.9 plus 5.12 gives me an answer from the calculator of 132.02. Now, going back, I see that I have one digit after the decimal, or one digit or one decimal place, right? And I see that I have 2 decimal places. So my answer has to have the same as the fewest number of decimal places So in this instance, 1 decimal place is the fewest, so I draw a line and then I round. So this case, my final answer is going to end up being 132.0, and my unit is going to be milliliters, right? Next one we're subtracting. So it's 132.60 minus 8.205. And the calculator tells me that that answer is going to be 124.395. So again, because we're subtracting or adding, we are going to be assessing based on decimal places. So 132.60 has 2 decimal places, and 8.205 has 3 decimal places. So that means that my final answer has to have the fewest number of decimal places, so I count and then I round. In this case, the 5 can round that 9 up. So I'm going to report my answer to be 124.40, and in this case, it's just going to be grams. Sometimes, though, doing it linear like this is kind of difficult to see. So I want to show you another way to look at it. So if I took 126.9 plus 5.12 and I added it up and I got 132.02, what you can do is you can simply just find the fewest number of decimal places, draw a line, and then round accordingly. You can do the same thing with the subtraction. So we can do 124. Nope, that's the answer. 132.60 minus 8.205, and you get 124.40, and then you locate that the fewest number of decimal places and just draw a line, and then you round. That's not 40. I'll erase that and make that better. It should be 395. Okay, so but it's just a different way to look at it, but sometimes it makes adding and subtracting with significant figures a little bit easier. Okay? So, questions about that? All right. Here's a bunch. Why don't you give this the old GHS try? So it looks like most of you have managed to work your way through those 3. So let's take a second and talk about them. So 33.5 plus 210.62. Because we're adding, it's based on number of decimal places. So that means that 33.5 has 1 decimal place, 210.62 has 2 decimal places. So even though the calculator gave me 244.12, I can only report to 1 decimal place, so I got 244.1, and my unit is grams. In the case of 63.854 grams divided by 1.20 milliliters. Because it's division and not because it's division, it's the answer report is based on significant figures. So I put that in the calculator and I got 53.211666667. I then went back and I assessed. So 63.854, I drew a line because there's a decimal going toward the right and counted everything had 5 sig figs, and 1.20 because there's a decimal I drew a line in, those had 3 sig figs. So my answer had to have 3 sig figs. So in that instance, I rounded the 53.2116666 to 53.2. My unit is grams per milliliter. On your paper, the hole punched out the 4. So you had 91 divided by 9.7, which is 2 sig figs divided by 2 sig figs, and you got 9.3814432299. So wandering around, most of you decided that you needed to have 2 sig figs in your answer, so you rounded. So you went 9.3, that 8 rounded the 3 up, so you got 9.4 meters per second. But if you were looking back at the notes when I upload them to Google Classroom, and you're going to be like, where did the 4.91 come from? Well, it came from the fact that yours got punched out and mine didn't. So 4.91 divided by 9.7 is 0.506185567. It was 3 sig figs divided by 2 sig figs. So that means that my answer has to have 2 sig figs in that instance. So I got 0.51. But either way, most of you look like you had a pretty decent idea of what's going on. Questions?